Assalamualaikum to Madam Nur Alina. Today, we would like to present our report on factor analysis on Major League Baseball in the seasons of 1986 and 1987. First, I would like to introduce each of the group members. I am Amira Atika and the other two members are Muhammad Firdaus and Nur Shara. We are from group CS2415T1. For introduction, the background study is about Major League Baseball is a North American professional baseball institution that was established in 1903 as a result of the merging of National League and American League. This study is about Major League Baseball data set in the seasons of 1986 to 1987 that was published by Collier Books Macmillan Publishing Company in New York. Next, for problem statement of this study shows that there are many variables in the data set which have caused many factors to be related to each other. Therefore, factor analysis is used to conduct in the study. For research question, first, how many factors can be identified in simplifying the number of variables in the dataset? Second, what is the best method of estimation in factor analysis? Next, there are two research objectives. First, to identify the number of factors in simplifying the number of variables. Second, to determine the best method of estimation in factor analysis.
For the methodology, first we have prepared a flowchart of our research which starts with the data collection method followed by data preprocessing and then model assumption testings. After that, we conduct the model fitting, model validation, and lastly, we interpret the results. Next, we have the data description. For this research, it was easier for us to just obtain a secondary data. We used a data from the website kaggle.com named Hitters, which has variables describing the Major League Baseball in the seasons of 1986 and 1988. The data has a sample size of 322 with 20 variables. For this research, we only use 16 variables as shown in the table here. 4 of them are excluded from the study. For the data preprocessing, we study the data to check the existence of missing value and outliers. 4 variables excluded from the research are salary, new league, league, and division. Salary is excluded because of the existence of missing value and it is a ratio scale. Next, the new league, league, and division are also excluded because of its ordinal scale nature. The data preprocessing is followed by model assumptions. For factor analysis, we do the model assumptions based on 2 testings, which are the Kaiser-Meyer-Olkin measure of sampling adequacy test and Bartlett's test of sphericity. For KMO, how to know the factor analysis is suitable to be used value of KMO must be greater than 0.5. Next, for the Bartlett's test of sphericity, when the p-value is less than alpha 0.05, the factor analysis is suitable to be conducted. Last, we have the methods in factor analysis. First, the methods of parameter estimation includes the principal components analysis and the unweighted least square. Secondly, the components in methods of parameter estimation includes the factor loading, specific variance, commonalities, and the residual matrix.
In results and discussion, we use SPSS to analyze and produce output to make interpretation. There are 2 tests used in model assumption testing. First, KMO test. The value obtained is 0.726, which is more than 0.5, which indicates that the data set is suitable to use factor analysis. Second, Bartlett test. The p-value obtained is 0.000, which is less than alpha 0.05, which indicates that the correlation matrix is not equal to identity matrix and it is suitable to use factor analysis. Principal component analysis is one of the methods of estimation in factor analysis. Based on the script plot, we know that there are 3 factors can be retained, which is factor 1, factor 2, and factor 3 because of the eigenvalue is more than 1. Based on communalities table, all variables excluding putouts are considered as ideal factor because of the communalities values are more than 0.5. Based on component matrix, by using the standard cutoff at 0.5, there are 13 items in factor 1, 6 items in factor 2, and 2 items in factor 3. Lastly, in rotated component matrix for PCA, using Varimax with Kaiser normalization, there are 7 items selected in factor 1, 6 items selected in factor 2, and 2 factors selected in factor 3. These variables are chosen based on their factor score more than 0.5.
The next method is unweighted least squares. From the script plot of unweighted least squares, it shows that only 3 factors will be retained. This is because of the eigenvalues is more than 1. If we look at the line graph, at factor 4, the line fluctuates at factor 4, and it shows that from factor 4 and onwards, for each consecutive factors, it indicate that the eigenvalues is less than 1. Next, from the total variance explained table, it shows that only 3 factors will be extracted since the eigenvalues is more than 1. Hence, the percentage of total variance explained of 3 factors which is extracted is 78.995%. Next, from the commonalities table of unweighted least squares, it shows that all the variables except put-outs and errors are considered as ideal factors since the commonalities value are greater than 0.5. The variable put-outs and errors are not considered as ideal factors. This is because the commonalities value is less than 0.5. The factor matrix of unweighted least squares, this is before the rotated. It shows that 3 factors were extracted given the eigenvalues is more than 1. By using the standard cutoff at 0.5, there are 13 items in factor 1, 4 items in factor 2, and 2 items in factor 3. This is the rotated factor matrix of unweighted least squares. The table shows for rotated component matrix of unweighted least square using Varimax with Kaiser normalization. Same as before, there are 3 factors extracted given the eigenvalues are more than 1. By using the standard cutoff at 0.5, there are 7 items in factor 1, 6 items in factor 2, and only 2 items in factor 3. The next part is residual matrix. This part is to determine from the objective 2. For the second objective is to determine the best method of estimation in factor analysis. For the PCA, it has 29 non-redundant residuals with absolute value greater than 0.05. For the residual matrix of unweighted least squares, it has 14 non-redundant residuals with absolute values greater than 0.05. Hence, it shows that the unweighted least squares is the best method of estimation in factor analysis since it has less non-redundant residuals compared to PCA or principal component analysis.
To conclude our findings, Factor 1 is named as career of player during Major League Baseball. There are 7 items of the factors which include career at-bats, career runs, career hits, career run battles, years, career walks, and career home runs. Next, for the Factor 2, which is identified as involvement of player in the field in 1986, the items have 6 which include run, number of runs battled, number of at-bats, number of hits, number of home runs, and number of walks. Last but not least, Factor 3 is defined as number of assists, which the item only has 2, which is the assist and errors. To get better results for this study, it is recommended that the sample should be minimized to achieve higher levels of commonalities and higher ratios of the number of variables to the number of factors when conducting factor analysis. That's all from us. Thank you and Assalamualaikum.